I didn't dress up this year. I'm kind of lame.
I usually don't. I don't really get into Halloween much, but I decided, hey, I'll do at least a Halloween shirt.
Yeah, I like that. That's cool. I have orange stripes. That's about as Halloween-y as I got today.
It counts, right?
That's what I'm telling myself. Okay. Thanks for meeting earlier. I appreciate it.
Oh, yeah, you're welcome.
Okay. Well, do you have questions about anything you want to discuss first?
Not really. I mean, I went through and I was looking at the reading and that for the section, and it seems pretty easy.
Yeah.
I'm just kind of confused as to like the graphs. Like I've seen where in like a video they do like the box plot, and then another video they're like, oh, the histogram is fine to do for the answer, and I'm like, wait a second here.
Yeah.
So, but other than that, it was fairly easy.
Okay. Yeah, I agree. It is kind of weird that they switch up on the graphs. It probably doesn't matter too much though.
Probably not.
All right. You ready for the quiz?
Yes.
Okay. Do you have it up already?
Uh-huh.
Okay, perfect. So question 3. In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. I'd say that's true, right?
Yeah.
Okay. What requirements need to be checked when performing an ANOVA hypothesis test? Data in each group are normally distributed. Variances are equal in each group. I think it's all of them.
Yeah.
Okay. Question 5. To check if each group is normally distributed, do the following. Construct a scatter plot of the data, a histogram, or a QQ plot. I think it's QQ plot. Yeah, I think it's QQ also. We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. I think it's that one.
Yeah.
I don't even need to keep reading. Okay, an ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? Well, I know there's a simpler way to figure that out, but there's 6?
Yeah, I'm getting 6 too.
Okay. Yeah, I think that's 6. That's a weird question. Okay, the data in soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. If there are 5 types of shoes and also just wearing socks for a total of 6 groups, each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball and patch of the target to the center of the target. So the smaller numbers are more accurate. What is the minimum variance for the 6 groups? Okay, I haven't put that in yet. I wish there was an easy way to clear all the data from the tables.
As far as I know, what you could do is just copy paste it over top of the information.
Yeah, that's kind of what I do too.
I mean, it's either that or you go through and highlight them all and then hit your delete key.
Yeah, I wish that takes more time.
So if it's asking for the smallest variance, wouldn't it be variable 3?
Let's see. Yeah, which is group C. Oh, it just wants the number. Okay.
Yeah.
Yeah, so 27.208. 29. What is the maximum largest variance for the 6 groups? Which is 53.158.
Yeah.
Okay. Question 10. The test for equal variances is satisfied for these data, which I'd say is true. Because the largest is not more than 4 times bigger than the smallest, right? Is that all that determines it?
Yeah.
Okay. 11. Construct a QQ plot for each of the 6 samples. Each of the 6 samples are approximately normal based on what you see in the Q plots. All right, let's see. I feel like I already did this for the homework, but I can't remember what the answer was. Or for whatever we did.
Yeah, I know we did. And of course, they're deciding not to work for me, so.
Oh, okay.
I remember correctly, if this was part of the reading and that I remember right, I think, I want to say yes, it was true.
Yeah, I think so. I'm checking right now. So far, they look good. I mean, it's hard because sometimes they say it's good, it's close enough, and other times they say it's not close enough when they kind of look the same to me. So sometimes it's kind of like, well, why is that normal when this other one isn't, if that makes sense.
Right.
So I don't feel like it's very consistent.
No.
So it's like, well, I say that's close enough, but someone else might think it's not close enough. I wish there was a more precise
way of knowing.
Like, yeah. Well, they are all basically going to share. I'll say true. I think you're right.
Okay.
Close enough, at least. In my opinion. Okay, perform an ANOVA test and observe that the p-value is 0.081. Then remove the SOX data and perform the tests again. What is the p-value when we remove the SOX data? Let's see. At 0.309.
Okay. And I just got mine pulled back up.
Okay.
So we're doing everything but the last one. Let's see.
Yeah.
Okay, what did you say you got for the p-value?
I got 0.309.
Okay, the p-value that I get with everything but the SOX is showing me 0.286.
Okay, let me see. Was the SOX the last one?
Yeah.
Okay, let me just copy and paste it and see if I do the same thing.
Oh, I just redid it and now I'm getting 0.309.
Oh, okay.
Must have did something wrong.
You know, I realize the more that I use like the same, I don't know what this is, sheet or whatever, it seems to get messed up,
Yeah.
which is really annoying. Okay, well, good. So got the answer. The test statistic for an ANOVA hypothesis test is an F statistic. Is the value the area to the right or left?
My understanding is it's always going to be right.
Yeah, that's what I think too. Okay, 14. Researchers at Consumer Reports analyzed 3 types of hot dogs: beef, poultry, and meat, mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met. Okay, so if we get the calories,
Want it all just for the hot dogs?
yeah.
And so are we considering that the meat or the beef?
So all of them.
All of
so
them?
yeah, so between the beef, the meat, and the poultry.
That's right, doing 3 QQ pots. Gotcha.
Yeah. So the third variable, it doesn't seem very good to me. It doesn't seem too straight. It's a little bit of an S. But again, like maybe someone else would come and say that that looks normal. It's very frustrating to me. Oh yeah, that one doesn't look good either.
Even the meat looks like it has a little bit too.
Yeah. I feel like the meat and the poultry both look a little
Lost.
skimoffice. Yeah. Because they're not very straight.
Yeah, I agree.
Yeah, because like I'm trying to get my camera over. You can see it. Yeah, because it kind of goes like this. Does that mean it's not very
Move it over
straight?
to the left a little bit.
Sorry, I can't move my camera anymore. Let's do that. There we
Yeah,
go.
right there, Yeah, that's not straight. My understanding is it has to be pretty much even with the dotted line. And if there's
Okay.
a curvature at all, then that means that it's
Right. Okay. Okay, good. I'm glad we both agree. So, but then to look at the variances of them, the variances look fine, but the QQ doesn't. So, I would say the third one, the assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, but we can assume the variances are equal.
Right.
Okay. And 15. Run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. you should find that the degrees of freedom are 2 and 51, that F equals 16.074, and that p-value is basically 0 with a level of significance equal to 0.05. What conclusion can we draw? We have sufficient evidence to claim that all 3 hot dogs have the same mean. We do not have sufficient evidence to reject. I would say that we have sufficient evidence to claim that all 3 hot dog types have a different mean.
I would agree.
Okay. Sweet. Now 16, let's examine the sodium levels and do the QQ plots. Oh, it's kind of busy work in my opinion. I don't like it.
Yeah.
All right, well, let's just do the same thing, but with the other set.
Ooh. Beef has a little bit of a curvature there too.
Does it? Okay. I haven't put it in there yet. Yeah, it does, huh? It does look a little like S shape.
They all kind of do actually have some type of curvature.
Oh yeah, especially the last one.
Mm-hmm.
Okay. But then the variances again look okay. So I think it'd be the same answer then. It's not safe to assume each group comes from a normally distributed population, but we can assume that variances are equal.
Yeah.
Okay. Despite the possible problem with QQ plot for poultry, we decide to use ANOVA to determine if the mean sodium levels are the same for all 3 groups. The p-value. So the p-value is 0.179.
This is for the sodium. Put this in my thing. Yeah, that's what I got.
Okay. So then what conclusion can we draw about the mean sodium levels of the 3 types of hot dogs? So the P level is greater than the level of significance, so we fail to reject the null, which means we have sufficient evidence to claim that all 3 hot dog types have the same mean. We do not have sufficient evidence to claim that they all have the same mean. We have sufficient evidence to claim that all 3 hot dogs have a different mean, and at least one hot dog has a different mean. Is it the first one?
That's what I think too. Yeah.
Okay. Okay. So I'm gonna know it. That's weird. It was worded a little differently.
Yeah. Sometimes I don't like those type of questions because they're like, wait a second, they're all the same and I have to reread them several times.
Yeah. Okay, so it says that we missed a couple of them. First of all, question 4, sample means are all positive, data in each group for normally variances. So I guess it's probably the first one. Probably doesn't need to be marked.
Okay.
let's see, question 14. Let's examine the calories first. Construct QQ plots of the calories for each. See, this is what if they say that it's good enough. See, now I don't know what to say on that one.
Yeah, because according to this here, if the points in the QQ plot do not show distinct curvature, it is reasonable to conclude that the data are normally distributed.
Yeah. See, this is stupid. It shouldn't be a question because it's so like opinion based. It's not like we can just look at it and be for sure. Because like I don't think it looks okay, but maybe they're saying it is good enough.
Yeah. And then if the largest variance is not 4 times larger than the smallest variance, we assume the variances are equal.
Yeah.
Suggesting that the data is assumed to be normally distributed.
Yeah, this is frustrating. I don't know.
I wonder if maybe we could email and get an answer to that question there.
Yeah, that's not a bad idea. Well, I guess I'll just go along with saying that it's good enough. Should we just do that? I hope that's not a question on the test because that's just so debatable.
Yeah, very. Mm-hmm.
So should we just say for question 14 that it's the first one? That the assumptions have been met?
I would, yeah, see what it says.
Okay. So then 15. I don't know, it's 15 too. So if the p-value is less, we reject the null. There's evidence to say. Oh, that's why. It probably should have been, we have sufficient evidence to claim that at least one of the hot dog types has a different mean.
So the last one instead.
Yeah.
Okay.
I guess that's true. That makes sense that the hypothesis, the alternative is that at least one is different. It's not usually that all are.
That is true.
I should have caught that.
Mm.
17.
And I can send our professor an email on that on question 14, see if we can get some type of clarification.
Okay. Yeah, thank you. That'd be really great.
Yeah.
What should we put for 18 now? What do you think?
So for 18, that's the one with what conclusion can we draw about the sodium levels?
Yeah, so if p-value is greater, we fail to reject it, so we don't. So it's sufficient. I still think it should be the first one.
So if we fail to reject it, that means that we don't have sufficient evidence.
Oh yeah. We do not have sufficient evidence to reject the claim. Oh yeah, is it the second one then?
The second one.
Okay, you're right. Thank you. Okay, cool. Submit this and see if it's any different. Yay. Okay, we did it.
100%. Yay.
Yay.
All
Okay.
right.
Thanks, Ashley. Then if you don't mind just telling me what she says too, that would be awesome.
Yeah, no problem. We'll do.
Okay. Well, thanks so much.
Yep. See ya.
Okay, see you later.